All right, so 9.3%. The word percent can be broken up into per cent, and cent is their prefix for hundred. So we can look at this word as per hundred. In other words, for every 100. And that percent can be used in one of two other ways. It can be represented as 1 over 100 or 0.01 as far as the value is concerned. Of course, if I scroll up too quick, let me know. All right, so the first conversion that we're looking at is percent to decimal. Want to locate the decimal, move the percent 2 places to the left. Move the decimal, 2 places to the left, and then remove the percent sign. So we look at 25%. That decimal's to the right of the 25. You know, when you don't see a decimal, you're always supposed to know that it's to the right of the rightmost digit. So that decimal's to the right of 25, move the decimal 2 places to the left. And that's 0.25. 25% is 0.25 as a decimal. For 1.39%, move that decimal 2 places to the right. Notice we have an extra space that we have to give an account for, so we use a 0 as a placeholder. So that's 0.0139. Then the same thing for that 0.6. Make sure you use placeholders for your zeros. That's 0.006. We have 0.6%. Move the decimal 2 places to the left, 0.006. All right, questions on percent to decimal. Next one is decimal to percent, in which we will go in the opposite direction, pretty much the reversal of the process. You locate the decimal, move the decimal 2 places to the right, and place your percent sign. All right, 0.38 as a percentage. You move decimal 2 places to the right, place your percent sign, that'll be 38%. $2.7, move your decimal 2 places to the right. That's 0 as a placeholder, so make sure you use that. So it's 270%. And then if I have the number 5 and I want to know what percentage that will represent, decimal 2 places to the right. Remember that you have a decimal. They assume you know is right there to the right of the 5. Move that 2 spots to the right, and that would be 500%. right, questions, any questions? All right, let's scroll up. All right, next conversion, percent as a fraction. So we will look at the percent sign itself and replace it with 1 over 100. And then multiply and simplify if necessary. All right, so looking at 25%, you're going to replace that percent sign with 1 over 100. So doing that, we have this right here. Now, if we decide to, we can go ahead and multiply across, or we can cancel out depending on which way you want to do it. Don't forget, whenever you multiply your fractions, you can reduce first and then multiply, or multiply and then reduce. It's up to you. I just went ahead and recognized that 100, oh, 100 is 4 times 25. So then I went ahead and canceled out the 25 that was in that 100. And that left me with a 4 in the denominator. So that's 1 over 4 as my most simplified fraction. But if you were to multiply it across and got 25 over 100, that still should reduce to 1 over 4. Any questions? Any questions? All right. Same thing happens with, let me do that. 120%. So this time I went ahead and just multiplied across. First, I replaced the percent sign with 1 over 100. Then I multiplied across first instead of reducing first like I did in the last problem, just showing you both ways. So that gives you 120 over 100. Now when I go to cancel out or reduce in my fraction, these zeros in the back can cancel. That represents 10. So the 10s cancel in both 120 and 100, leaving me with 12 over 10. 12 is 2 times 6. 10 is 2 times 5, so I cancel out the 2's. And that leaves me with 6 over 5. All right, questions on that? I probably should do this. All right, so this next one is 33 and 1/3%. And so I wrote the note here, convert to an improper fraction. So that's what we did. Before we messed with the percentage, we converted to an improper fraction. So we took the 33 times 3 and add 1. So that'd be 100 over 3. So that same denominator stays there. It's 100 over 3%. And now you replace that percent sign with 1 over 100. And multiplying, I can go ahead and cancel out the 100. And that'll leave me with 1 where those places were. So that'll just be 1/3 as a final answer. All right, questions?
I'm so sorry. Could you explain that one more time?
Yep. First thing you want to do is take the mixed number that you have and convert it to an improper fraction. So you take the 33, multiply it times the denominator, add it to the numerator. So 33 times 3 is 99, plus that 1 is 100. And whenever you convert into an improper fraction, you always keep, that same denominator. So once you convert it to an improper fraction, that's 100 over 3, then we do the same thing that we did in the previous problem where we take 1 over 100 and replace that with the percent sign. So now
Got it.
yeah. So then you have 100 over 3 and then times 1 over 100, and those 100s, still have my wrist on. Then those 100s will cancel, leaving you with just 1 times 1 up top and then 3 times 1 up bottom, which is just 1/3.
Okay, thank you.
All right, not a problem, not a problem. Anything else? Anybody else? Make sure we're good to go before we move to another problem. All right. Next type is converting a fraction to percent. So we just did percent to fraction. Now we're looking at fraction to percent. So we'll convert the fraction to a decimal by division. Throw it in the calculator, get the decimal representation of that fraction. Then convert the decimal to percent like we talked about before, moving the decimal 2 places to the right. So if I have 3/4, that's the same thing as 3 divided by 4, which is 0.75. Then you move your decimal 2 places to the right, which is 75%. So same thing with 5/8. So 5 over 8, that's 5 divided by 8, which is 0.625. Move the decimal 2 places to the right, that's 62.5%. All right, any questions? Got it good before I scroll up. I think this is the last thing. Let me see, 1, 2. I got a couple things in here. Okay. All right. So looking at solving percent problems. If we want to set it up, solving, we're using a proportion. Then we do percent over 100 equal to your amount over base. Some people call it the top, the amount, the part, and the base, the whole. So it just depends on how you were taught. But the same thought process, just different terminology. Or if you want to use an equation, you can do percent times base equal to amount. And when you set up this equation, you have to use the decimal representation of your percent. Not in this case, though. Notice the percent is over 100, so you're not using the decimal there, but here you're using the decimal. And so over here, I emphasize that, you know, your base is considered your whole or your total, and the amount is considered the part. That's the same thing I was saying up there. All right, let's look at a problem. All right, so the average size of a new single family house in 2014 was 2690 or 2,690 feet squared of square footage. This is 158%. Write that one better. 158% of the average size of a new house in 1980. What was the average size of a new house in 1980? Round to the nearest whole number. Give you a few minutes to write that. A few seconds. All right. So when we look at the percent, that's 158%. So we want to write that as a decimal, that's 1.58. Now, when we look at what we have here, we have 2,690 feet squared is 158% of the average size. And it says, so what was the average size of a house? So your amount is always going to be the percent of the base. So that means, and of mathematically is always multiplication. So let me see, I set it up both ways. So my base, the base amount, or the amount that I'm trying to figure out, is my X in this case, and the amount that I have that's associated with the percent is the 2690. So in other words, when you look at your percent is supposed to represent the amount. So if I have 2690 and it says this is 158% of the average size. So 2690 is 158% of our base. So we can go ahead and set it up according to what I wrote it right here. This is our amount. Our amount is our top number. Base is the bottom number. And you took that 158 and placed it over 100. So if you want to use the proportion equation, that's how you would set it up. If you want to use the regular equation, notice you do 1.58, which is in decimal, times your base equal to your amount. Either way, you'll get the same answer. It doesn't matter which way you decide to go with. It's up to you. It's up to you. And so I believe I solved it both ways. Yeah. So I'll show you both ways. I don't believe you don't have to do both ways. Once again, you just have to do one of the ways. If you decide to use the proportion, 158 over 100 equal to 2690 over X, you always can cross multiply, you know, with your proportions. You always cross multiply. And so it'll be 158X equal to 2690 times 100, which is 269,000. And then divide by 158, that's 1703. And it said round to the nearest, round to the nearest whole number. So that's 1703. Whole number is this 2, and that 5 totals to round it up. And then here, PBA, way to remember it, percent times base equal to your amount. So I went ahead and solved that. So I have 1.58x equal to 2690. That's down here. Then I went ahead and divided by 1.58, which still gives me that 1703 as an answer. So either way, whether you use a proportion or just set it up as an equation, you should still get the same answer. Just all about assigning which part is your base and which part is your amount, making sure you're cool on that. All right, so questions on that one before we do another one. Make sure we're okay. All right, can I scroll up? All right, so according to the Bureau, in a recent year, the average American family had an income of $66,877 and spent $6,659 on food. What percent of the family income was spent on food? And it said round to the nearest percent. I'll give you a chance to write that down. All right, so we want to know the percent. It says what percent of the family income was spent on food, round to the nearest percent. And notice we have a total income of $66,877. And part of it is spent on food, $6,759 spent on food. So when we set up what we know, it's right here. Let me erase some of this stuff. Our percent is our unknown, that's our X. The base is the 66,877, that's our total amount, our base. And then the part is the amount, the 6,759. All right. So we want to, I decided to set this one up as a proportion. X over 100 equal to 6759 over 66,877. We can go ahead and solve. You can either cross multiply, or if you just want to multiply both sides by 100, that'll work as well. 100s cancel, leave you with just X on the left. And 6759 times 100 is 675,900 right here. Divide that out, maybe 10.106. And that's just 10%, rounded to the nearest percent. All right, questions, any questions? And the purple is just me solving it as an equation. And just reminding you right here that it is going to be in decimal form when you solve it out. Like I said, you only have to do one method. For some reason, I did both of them in both cases, but maybe somebody asked about it probably when I was teaching it the first time. So that's going to be X, which is your percent, times the total. It's going to be equal to the amount. So percent of your base is equal to the amount. So as always, your percent times your base. Remember it said PBA, percent times your base is equal to the amount. So just emphasizing that one more time. So if that, helps you to remember better, PBA, percent times base equal to amount, or percent times the total is equal to the part. And so we divide both sides by the 66,877. That still gives us the 0.10106. But once again, if they want the answer in percent, this form gives you the answer in decimal. And you just need to move your decimal 2 places to the right. And that will be your answer. All right. Questions? Any questions? I think percent increase is the last thing. Yep, it is. All right, so last thing out of this section. Percent increase, percent decrease. You find them the same way. You take the amount, if for the percent increase, you find the amount of increase divided by the original amount, and then multiply that times 100%. For the percent decrease.
Can you go back up some?
Oh, you talking about back here?
Yes.
Girl, you let me you gotta start talking a whole nother thing, then you tell me to go back up. See? I was in my flow and all that. Let's see. But of course, it's not a big deal. I'm cool. So let me know when you finish.
I'm finished.
All right, cool. Yeah, but never hesitate to let me tell me to scroll back up. I don't want to leave nobody behind. So percent increase and percent decrease, you find them the same way. Find the amount of increase for the percent increase, divide by the original amount, multiply times 100%. For the percent decrease, find the amount of decrease, divided by the original amount, multiply by 100%. Or maybe I should have done dark blue. All right. Pretty good before we do a problem. I'm gonna scroll up. All right, so it says find the percent increase in the federal debt from 2005 to 2010. All right, so they gave us a chart. And so if you were to look in 9.3 at the examples, they gave you a chart. And in 2005, it was 7.91. And if I'm not mistaken, these are in million. Might even be a billion. Got to look at that chart, but 7.91. And then in 2010, it was 13.53. So to find the amount of increase, you subtract those two numbers from each other. Same thing if you want to find the amount of decrease, just subtract those two numbers from each other. Then you take that number, divide it by the original, and multiply it times 100%. So our original in this case was 7.91 because you start in 2005 and get to 2010. So 5.62 divided by 7.91, multiplied times 100%, that'll be 71.04. That's right, we're talking about federal. So it should be trillion. All right. Questions on that? Like I said, it's the same process for percent decrease. You would, subtract the two values, divide by the original, and multiply 100%. All right, questions.
Would you still subtract for the decrease as well, or would you add the numbers?
Subtract, do the same as that process.
Okay.
Mm-hmm. It's just that these numbers would have been, the only thing, okay, let's say if it was decrease, let's say if it was 2000, I said 2050, 2005, let's say if it was, I don't know, 10.9%, $10.9. And then 2010, it would have been 6.4. I put it 5 strong, okay. It would have been a decrease instead of, these numbers went up. It went from 7 to 13. If it was decreased, it would go something like 10 to 6. It would still be the same process. You subtract these two numbers, and it would be 4.5. And then I would divide by the original amount, which is 10.9, and multiply by 100%. Yep, be the same process. Mm.
41%.
You said 41%?
Yeah, 41.28. Yeah.
Okay, thank you much. I was looking at about to do the calculation. Thank you. All right. So, questions? Any questions? So, it's important that you try this stuff out.
I actually do have a question, but it's not about this. Like, when are you gonna post the recordings for 9.1 and 9.2?
Probably tomorrow. Should be able to get to them tomorrow. I just couldn't get to them before now. That's some stuff that came up. But Friday normally is my day between Friday and Saturday, but I should be clear to do it on Friday, this Friday. So, but that's tomorrow. So yeah, I'll knock them out tomorrow. Yeah. If I can get to them tonight, then I do them tonight, and I don't have to worry about it on Friday. It's just all about timing because I have classes. Really, tonight I have class all the way till 9 o'clock. So it just depends on my days. I'll be rolling, man, from 8 to 9 sometimes. So, yeah.
Okay, thank you.
Yeah, not a problem. All right. So next class now for chapter 9. That's it. That's 9.1 and 9.3. So next class will be a review day. That's going to be the 23rd, right? Yep, 23rd. Review day. I won't cover any new material. So that will be on you to bring your questions. Like I said, take this weekend out, get into WebAssign, see if you have some questions that you want me to cover. And see if you have any, go to the test review. See if there's anything in the test review you want me to do. Test review will set you up for the test itself. So make sure you look at the test review and see if you see some problems in there that you want me to knock out. And then we'll go from there. But I will not cover any new material on next class. But I'll be looking for you guys to bring something to the table so that I can cover.
Is this class over? I'm sorry. Are you about to end class?
Well, I'm done with lecture now. If people have questions, then I'll address questions. Yeah.
Well, I was just having technical difficulties before you started the percentages, because that's when I came into class, and I was wondering how much did I miss. I didn't think I missed too much, but now I'm a little concerned.
All right, I'll scroll it up and let you copy the notes. Yeah, it's
Okay.
not a big deal. But
Thank you.
yep, no problem. But before I do that, and anybody else have anything else before we close out the class? Anybody have any questions, concerns, comments, anything? Anybody? All right. So like I said, all we did was 9.3 today. I didn't want to jump into another chapter because that's it for chapter 9. So I try to, compartmentalize the lectures and everything like that. So once again, try the stuff out. If you have questions, bring them on next class. That whole class will be for you guys to ask whatever questions you want to ask about anything. You know, even stuff on chapter 7. If you got stuff, because those things are still open as well. Ask those questions on next class, and we'll knock them out. All right. So you guys have a good one. Have a great weekend. Be safe, and I will see you on Tuesday.
Thank you.
Thank you. All right. So I didn't catch your name because I didn't look, but who needed those notes? You said percent.
Joanna Piercy.
Okay, Miss Piercy.
Yes.
Let me know where to stop. I don't know where we
You have a good day, Doc.
All right, you do the same, sir. Appreciate it.
9.3. Wow, I didn't miss much. Okay, so
Mhm.
percent is 100, 100. Okay, you can scroll. Percent to decimal. Okay, right there.
Oh, right here?
No, go up a little.
Oh, keep going.
No, I was saying you could have stayed right there.
Oh, okay. I thought you said go up a little.
Yeah, right there. My bad.
Okay. No, you good.
Because I'm screenshotting it,
Just
so.
saying.
This is
Okay,
good.
cool. Yep, just let me know.
Okay, now you can go down a little bit. Got you. Okay.
Oh, not moving. Go up. There we go.
Yeah. Okay, thank you.
Mm-hmm.
Okay, so can you go down so I can see all the steps
Right
for the
here.
percent as a
Right down.
fraction? Okay.
All right. Not sure where you want to stop here.
Yeah, that's right. Good right there. What's the point of narrowing down the percents to fractions? Like they'll just ask us that on WebAssign or something.
Yeah, it would just be convert the percent to a fraction.
Okay.
And that would be the process. Yeah.
Okay, you can scroll down. Thank you.
Mm-hmm.
You can scroll down. Okay, just scroll. Scroll down for the solving percent problems. Okay, go down. Okay, I'm good. I'm caught up. Thank you.
Okay. Not a problem.
All right, have a nice day.
All right, you do the same. All right.
My bad.
You good? Anybody else? Everybody else good? All right, you guys have a great weekend.